You guys can see my screen and page 193, basic error handling. Now in Java, we learn about try-catch block. That's one way of doing error handling. This is a totally different way of doing error handling. Again, you got to remember, it's a totally different language. It has its basis in something very old. So there are different types of errors. You know that there are logical errors, which is the problem in the programmer's logic or thinking. There's a runtime error, the things that may occur during runtime. And then there are syntax errors. For syntax errors, when you are compiling, it tells you right away what your errors are, and then you can go and fix those errors. But for logical errors, you can't really see them happening. Similarly, runtime errors can occur during runtime. And the whole main idea of this chapter is that when a runtime error occurs, how can you handle it at program level? As opposed to giving everything away, try to handle a few things inside, like a try-catch block. Similar concept, but dealt slightly differently. So on page 193 of your books, as the chapter opens up, it says there are types of errors. Some program errors can be anticipated. For instance, if a CL program contains a command to check for the existence of a file, you could reasonably expect that the file might not exist. So if a file does not exist, what happens? Your program errors out, your program crashes, gives the control over to the operating system, and operating system says, you know what, the file you're looking for does not exist. Instead of that, if a file does not exist, I will create it. You know, you can actually tell your program that if file not exist error occurs, instead of giving the control back, I want you to create the file and resume with the program. Is everybody following that idea about the error handling? Okay, cool. So when we talk about unexpected errors, that could be you're dividing by 0, or you're trying to look for an object not found, or there can be some errors from where recovery is not possible, like you have a power failure, or you had server was down, disk failed, that kind of stuff. So typically when errors are sent, you can ignore them, you can run them again, you can cancel them, you can delete them. You have a choice of running through your error messages and can decide what you want to do with those error messages, and then the system will act accordingly. Remember that every error message that gets generated, there are two things to know. Number one, there is always a message ID. The message ID starts with the letters CPF, and I'll tell you why when we go a little bit into the chapter. Followed by a 4-digit code. The 4-digit error code can be any hexadecimal number. Each digit can be any hexadecimal number. Generally, these are between 0 through 9. Each digit is between 0 through 9. Do you guys know what hexadecimal numbers are? Hexadecimal numbers?
Yes.
What are they?
What are they? Actually, when I was in internet programming, that time I used that.
Oh,
It's
you took internet programming last year? Or you're taking
yeah.
it now?
Not now. I did already.
Oh, okay.
Yeah. So
Anybody else who is in internet programming should know hexadecimal numbers.
So
Hexadecimal, how many numbers are there in hexadecimal? Like total number of unique representations?
16.
16.
16. So it's 0 through 9 and then A through F. Okay, A0 through 9 and A through F. That's hexadecimal. So each of these digits can be any hexadecimal number. But again, every error has a message ID and it has a message. What is the error all about? The other funny thing is that in control language, just because you have a message ID it doesn't mean it is an error. Some of the message IDs are for a successful run, so that's why you will not see everywhere we will use the word error. We will rather say message ID and a message. Message ID is a unique representation, and message is the details of the unique representation. So all the messages that are generated are stored inside a special file, which is being talked about on page 194. The description of IBM supplied messages are stored in a special file called message file. This message file is an object. It is of message type. It is a file type. Okay. And it is very similar to a database, but they're used specifically for description of the messages. I'm at the bottom of page 194. Most messages that can be generated within a CL program are stored in an IBM supplied message file. This is the name of the file, QCPF-MSG. That is the name of that message file. It is placed inside a library called QSys. You can display the contents of a message file by using a display message description command or work message description command. So there are two different commands that you can use to peek into the message file. On page number 195, you have been shown, if you type, I want to work with message description, WRKMSGD, it shows you the message IDs and it shows you the message text. Where you see &2 and &3 in your, window and your picture, like here, the %2 and the &2 and &3, those are placeholders. So during runtime, those placeholders are replaced by an actual object name. For example, if you are looking for an object called Books 101 in the library, ITPA 111. So during runtime, it will say object Books 101 in the library, ITPA 111 not found. So those are placeholders, which will be replaced by actual objects during runtime. And all of these are the message IDs. Okay. Any questions so far, guys? I want you to read a couple of pages from the book. They are called the gray boxes. I want you to read pages 196, 197, the gray box. Pages 196 and 197. And read the gray boxes. And give me a green check when you're done. So these two pages talk about check object command, which is a command to go out and check to see if certain object exists or does not exist. And it comes back if an object does not exist, it generates an error message. If it does exist, then it is okay. Also on page 197, it talks about the object authority. And it talks about the different values of that. On page number 196, all of you will see a note section at the top. That note section at the top will tell you why all the error messages start with CPF. So go ahead and read the note section at the top of page 196. And whenever you are done reading the top portion of page 196, also read the paragraph right at the top of page 197. So that probably would have helped you understand as to why CPF are the first three letters of all the error message IDs, and would have also helped you understand about the hexadecimal and what exactly do we mean by the last four digits. They are the unique numbers. So we will now start with our next topic on page 197, which is about monitor message. Monitor message is the message command, which is called in case of an error. It's actually a command, monitor message. The monitor message command goes like this. Have a look at this slide that I'm presenting to you. That monitor message requires that you must provide it with a message ID, that there has to be a message ID which tells the monitor message that what kind of error you are trying to catch. That's why it needs to have a message ID. Now, these are two different ways of writing it. This is called, if you remember, this is the keyword notation, and that's a positional notation. So either way you can write it. The last parameter is exec. What does that mean? That means if this error is generated, or if this message ID is generated, what will be my plan of action? What will I do So whatever you want to do, that's what you will put in this area in the parentheses. Okay. For example, if you are doing CPF 9801, 9801 means object not found. So if the object is not found, I want to run a CL command here to create the object. So I will just do it right there and then. So as soon as the error is triggered, I will take care of it right away. Okay. For example, have a look at this example. This is called the command level mon message. What does that mean? That means the mon message is only associated with one command. And which command is it associated with? It is only associated with the instruction right above it. Okay. So is the mon message associated with this line? Yes or no?
No.
No.
No. Okay. So mon message is only associated with this line. So if you're checking an object, my file, and if my file does not exist, your program will crash and you will be handed over to the operating system. But if my file 2 does not exist, in that case, an error will be generated, but mon message will say, hold on a second, I will catch it. Because I have been assigned a message ID CPF 9801, which is specially designed to work with objects that don't exist. So you know what I will do? Since the object does not exist, I will create the object. And the program can then continue with rest of the code. And your program doesn't have to fail. Does that make sense?
Yeah, so you would have to put a mon message underneath the first line as well if you wanted to do the same for that one.
Exactly. Exactly.
Okay.
Okay. And this approach is called command level monitor message. That means you have to write one for each command. Now comes the question, is it possible to write a monitor message for a group of commands? No, you can't create a group. However, you can write a monitor message for the entire program. Like those are called the program level monitor message. These monitor messages must be the first line after all the declare instructions. So here, mon message CPF 9801 is now acting on behalf of all these commands, all of them. So if any one of these commands run into file not found or object not found exception, mon message will be called. The mon message will then execute the go to statement and your program will jump here. As opposed to failing, it will jump here and will come to an end. But it will come to, it's like landing softly versus crashing. You know, that's the difference. Did everybody understand this?
Yeah, seems to make sense there.
Okay, now comes mix. You can also mix. For example, you can say, well, you know what, at the program level, I want to have a monitor message, but I also want a monitor message at each or some of my commands. If not each, some of my commands. So for example, call my program, it doesn't have any monitor message with it. Send program message does not have any monitor message with it, but dump CL program has one. Check object has one, and add library list entry has one. Okay. So if any error occurs here, it will not just directly go here. It will only go here if the error is of this nature. Means if the item is already in the list, then this error will be triggered. If the file not found, then this error will be triggered. But if you run into any other error, such as you don't have authority over the object, then this guy cannot take care of the problem. Then who will take care of that problem? Then you'd have to go to the program level one. Does that make sense?
So far, I think.
Okay. Now, there are two more things to pay attention to. Number one, what is a syntactic difference between this line and this line? Syntax different.
Just the executable aspect.
Exactly. So the first one says, if there is an error of already in the list type occur, catch it, but don't do anything. Catch it, but don't do anything. This is a nice way of saying ignore the error. On the other hand, the second one says, if there is an error, I want to do some plan of action. So it is quite possible for you to catch an error and don't do anything. Do you see any other example in this example where you catch an error but don't do anything?
At the bottom.
Exactly. You catch an error, but you don't do anything. Okay. Now there is one more thing. Oh, where is that? Okay. There's one more thing I want to talk about here is, do you see CPF 0000? The CPF 0000 is not a message ID for any one particular error. Okay. CPF 0000 means it is the most generic message ID. It is a mask, means I can catch all kinds of errors. Okay. What does that mean? I can catch all kinds of errors. So that's why that is the most generic catch. So any command which is without a mon message and runs any kind of an error, that guy will catch it. That's why you will not find any sequence starting with 00 in the last two digits, because there's a reason behind it. If I say CPF 9801, it means I will trigger this only if this particular error occurs. But if I replace it with 9800, that means any error in the CPF 98 series, it could be 01, 02, 03, 04, all the way through 99. Any error in CPF 98 series, that guy can catch it, because the last two digits are mask 00. Does everybody understand this?
Yes.
Okay. Okay. Now moving to generic message, which I've already told you, the last 200 means you can see here, it can catch any 9800 error. And all zeros mean it can catch any errors on all errors. Mon message can specify up to 50 messages. So like there, over here, look at it. It has two message IDs. What does that mean? That means if the error is of this type or the error is of this type, it can catch both of them. And in either of the two cases, I want you to go to errors. Okay. Now look at page 202. There is a table on page 202. I want you to read the first column and the second column of the table on page 202. Similarly, if you look at the very last line on the slide, check object has a list of message IDs, CPF 0001, which means error found on command, all the way to CPF 9999, which means function check unmonitored message. All of them are listed here. If any one of them occur, it will call the go to errors. Similarly, the authority is what you learn on page 197. And the authority parameter basically allow you to check for authority on the object, and all means check all authorities. Here's another example. Sometimes you do not want to take the same course of action for all possible message IDs. So in that case, you can have multiple mon messages associated with the same command. So check object. If it is message ID 9801, I want to execute the command to create a physical file. However, if it is CPF 9802, then I want to go to a label called errors. So you have different plan of action for different message IDs. In that case, you can have multiple of them associated with a command, okay? Okay, now comes page 203. Errors with a non-message. By default, program level non-message will handle errors that occur for a command level non-message action. Use do group to alter the default behavior. For example, you have a check object command. If anything goes wrong with it, you have a mon message for that. But the mon message actually have an execution command in it. How about if that command fails, right? If that command that is supposed to take care of the problem, if that command fails, so I have a mon message for that command. You guys follow that?
Oh, yeah.
Okay. So that's what basically this does. Ignoring error message, we already talked about that. That if the mon message doesn't has an execution piece is pretty much equivalent to, you are planning on ignoring the message. Also, in some cases, like when you have a very generic message, like you can see over here in this example, right after the declare commands, notice we have a CPF 0000. That's the most generic error message. It can catch any type of error. But you as a programmer want to know what kind of error occurred. So in order for you to know what kind of error occurred, you can go to error, and we have another command called receive message. The receive message command has a parameter called message type of the value last. It can grab the last error message and can transfer that into a variable. And you can then display that variable to know exactly what kind of error occurred. There are a couple of other gray boxes I want you to read, pages 204, 205, then read the chapter summary. So pages 204, 205, gray boxes, then chapter summary, then we will go to hands-on. Okay, so give me a green check. I'll clear your current green checks. Give me a new green check when you guys are done.
I'm sorry, what did you want?
204, 205,
Cool. Okay,
and
was
then
making-
followed by chapter summary.
okay. Thank you.
Mhm. So guys, this was the last example we did. Can you guys confirm that this is the last example we did?
Yeah, I don't see anything past 18.
Okay, awesome. So we need to, first of all, work with for loop. So I'll start out with a new one, we'll make it a lot easier for us. Okay, so I'll start with a new member. I'll call this one CLPG, and this will be number 18. So it'll be number 19 for us. So CLPG number 19. And then this will be SP23. And this will be a CLLE. And finish. Please make sure that it shows up in the list, because with my afternoon class, there were a couple people who did not pay attention to that, and they had to retype the whole example because the member they created never registered in RDI. So please make sure that it does occur in your source physical file. Okay? Just the basic skeleton of the code. I'll declare one variable called count of type integer, length of 2, and initial value of 0. If I were to run a loop that goes from 1 through 10, I can just do like this: do for count from 1 to 10. And it auto increments by 1. I got to end the loop with end-do. And then I have send program message. Message count is, and then I display the value of count. Now, before I compile this code, can one of you identify what mistake I made?
Do you have to make count a string?
I want to leave it as a number because I have to go from 1 through 10. I cannot go 1 through 10 if it was a character.
Sorry, I meant like in the send program message, make it a string.
I have to convert it to a, how do I do that? How do I convert an integer to a character?
Can you use the substring method?
No, substring only works if it is already a string.
The change var command.
Change. Oh, no. That is to change the value of a variable. Here you go. Jacob has it. You got to enclose this in Okay, you didn't close it like that. I don't like that cyan green color or like love neon green color. So I tried to change mine to a different color. Okay, everybody got this? You compile it, you save it, you compile it, and you run it. And you have to run it in the green screen because it has a send program message. And it should tell you the count is 11 because the loop runs from 1 through 10. So when the loop terminates, the value of count is 11 because 10 is a valid value.
Excuse me, sir.
Yes,
I got the error.
where?
Mm, it's the error says no labels used in program.
Right, did you use the start colon and end colon? Okay, now tell me this, do you have the line where you're saying it is an error? Do you see an orange triangle or do you see a red circle?
Um,
Where do you see that message that,
Message. It's I can see that message after end program command.
okay, okay. Can
Yeah,
can you share your screen?
sure. One moment. Okay, are you able to see
Yeah.
my screen?
Yeah, you're missing, before end PGM, we put end colon.
Oh yeah.
Go to that same line, end PGM, and just type end colon. Just type end colon. EN, oh,
Yeah. End
D colon.
colon.
No, the actual colon. The
Oh
simple
yeah, got
colon.
it. Oh,
Yeah,
okay, got
yeah.
it.
Yeah,
I'm sorry. Okay, and
colon, and then you got to put an E for, yeah, that's it.
that's it.
That's it.
Okay.
Yeah. Now compile.
Okay.
Now you can go to the
Okay.
green screen and call it.
Oh, okay. So it matters. This symbol is matters.
Yes, because it is a label for the program end.
Okay, got it. Okay, thank you.
Anybody else has any issues? All good?
All good.
All good, okay. So all this program does, it just goes from 1 through 10. The loop goes from 1 through 10 for the variable count. And when the loop terminates, the value of count is 11, and we are displaying that value just to show that the value of count did change from 0 to 11. Okay? So now let's move on to our next example with for loop. So we will save this example as, click File menu, Save As, and change the 19 to a 20 and click OK. And please make sure that when it is saved, you can see the 20 in the list. Okay, please make sure that you can see the number 20 in the list on the left-hand side. Okay. Now I will declare two variables, count and count2. There are two variables, count and count2. Same type, same length, same starting point. The count2, the count will go from 1 to 10. But for the count2, every time count runs, I want count2 to be incremented by 1, but differently, slightly different approach. One is automatically going as a loop counter. The other one is incrementing inside the body of the loop.
I have one question. It's pretty simple. When you want a space without it taking over the other, instead of it covering the letter and starting.
You press the insert key on the keyboard.
Okay.
Okay.
All right. Thank you.
So now on line number 8, I will display the count is this. And count2 is this. Oh, I need to do the percentage care. Okay. I'll compile it. And then I'll run it. So it should now tell me the count is 11 and count2 is 10. That'll be the end results. Count 11 and count2 10. Who can tell me why? When they start at the same value, why do they have different values in the output? They both start at 0.
It's because you're doing the count 2 plus 1.
Yeah, but they're both incrementing by 1. So how come one is 11 and one is 10?
True.
And it is not a logical error if you're thinking in that direction.
Because you got started count one at 1 rather than 0.
They both are starting at 0.
Dang. Okay.
But you start here, you start from 1, right? Exactly. So, but
That's what I'm thinking.
but in the first cycle, this also became 1. Right? So when count was 1, count 2 was also 1.
Count 2 plus 1. Oh, I guess, yeah, you're right.
Yeah,
You're right.
yeah. So they are going in parallel.
Oh, let's see. That's a good question then.
The reason is when count was 10, count 2 also became 10. But when count became 11, the loop terminated. So count 2 was never incremented, but count was.
Okay, that makes sense.
Okay. That's why one is 11 and the other one is 10.
Gotcha. Count 1 killed the loop before count 2 got there.
Exactly.
Makes sense.
Everybody got this? Anybody still coding? Okay. We will now move on to save as. This as number 21. Again, making sure that 21 comes up in the list. I want to go backwards in my loop as opposed to increment by 1. I want to decrement by 1. So to make that happen, I will change this to 10. From 10 to 1 by -1. So now it will decrement by 1. It will decrement by 1 in each cycle. Till it reaches 1. Rest of the program, I'm leaving it the way it was before. So let me compile. And let me run. So for the same reason, count is 0, because 1 is a valid value. It terminates at 0. So the program actually runs, the loop runs for 10 times, but the count runs for 11 times because it also has its exit value. Where count 2 only ran for 10 times, which is when the condition was true. Okay. Now let's save as number 22. Again, make sure that you can see the member. We will now make a slightly different thing here. We will make the count run from 1 to 10, incrementing by 1. And we will increment, oops, get rid of this. We will increment by 3. Save the changes. So I changed the, oh, sorry, I should go from 1 to 10, my bad, from 1 to 10. And increment by 3. The count 2 is incrementing by 3. Count is incrementing by 1. Compile it. And run it. And this time you will see that count 2 will actually reach 30 because that's what it does by incrementing 10 times. Okay, now we will move on to our next topic, which is subroutines. Subroutines is basically where you have a module or a procedure that you can call, and it pretty much works like that. So we will start a new program or new member. We'll call this one CLPG 23, CLLE, we'll still declare the count variable of type integer, length 2, value 0. Now I'll create a subroutine. Subroutine, count subroutine. And you end the subroutine with the word end sub R. In control language, your subroutine must be the last piece towards the end of the program. You should not have any code outside of the subroutine after the subroutine. So if you want to call a subroutine, that call must be before the subroutine. So call subroutine, call subroutine, and count subroutine. Okay, so that's how you make a call to a subroutine. So this is a call to the subroutine. And this is a subroutine line 105 through 107. We'll now add some components to this subroutine. I want to change the variable count by incrementing its value by 5. If count is less than 5, then send program message And if count is greater than equals to 5, then the program message will be count is greater than or equals to 5. The final output should be count is greater than equals to 5. And the reason is because when I'm incrementing the count by 5 and count was 0, 0 plus 5 will change the value of count to a 5. So first if condition will fail, the second if condition will be true. As a result, the output will be count is greater than or equals to 5. Okay, everybody got this?
Yep, all good.
Okay, then let's save this one as number 24 and making sure that number 24 comes up in the list. And now we will write multiple subroutines. So let me copy this subroutine and paste it right below. I'll call this one subroutine 1, and I'll call this one subroutine 2. In subroutine 1, I will only change the variable's value. So let me delete these 2 lines. By simply issuing the command D2, I will delete those 2 lines. In subroutine 2, I will delete the first line, which is changing the variable. So first subroutine changes the value of the variable. Second subroutine checks. So now let me make 2 calls. subroutine 1 call, and subroutine 2 call. Save the changes, compile the program, and run the program. So you will see the same output, the exact same output. The only difference is we further modularize the code by moving the change variable in one module and the if conditions in the other. Everybody got this working?
Yep, working.
Yep, works.
Okay. Then we will save this one as number 25. And I will introduce one more variable because I now want to call the subroutine in a loop. So when you are working with the do while loop, you need to have a flag which starts out as true, but you want to change it into a false. So I will declare a variable called status of logical type with an initial value of 1. Okay. Then the first call, which is to the subroutine number 1, I'll put it in a while loop. So do while. The condition is as long as status remains true, I want you to keep calling the subroutine number 1. Subroutine 1 gets called till the status remains true. In the body of subroutine 1, where we are incrementing the count by 5, we know that the count will keep incrementing by 5. In first cycle, it will become 5, then 10, then 15, then 20, then 25, then 30. Like that, it will keep incrementing by 1. So we will write an if condition here that if count reaches a value of 50, as long as count is greater than or equals to, if count becomes greater than or equals to 50, I want to change the variable status to false. That way the loop will terminate. And in the conditions down below in count subroutine 2, I will just make everything 50. Okay. So we are running a while loop as long as status is true, and status will remain true until the status changes to false when count hits a value greater than equals to 50. So one subroutine is controlling the loop in the outer code, and you're sharing variables because they're declared global between the multiple subroutines, such as status or count and so on and so forth. So you compile. And upon successful compilation, you run program number 25, and you will see that count now exceeds 50, or is at least equals to 50. Everybody got this?
Yep, so far so good.
Yep.
Okay. Next, we will do our example with mon message, which is related to our today's class. So we will start with a new program. So create a new member. This will be number 26, CLLE, and we'll create a program. I'll declare a variable called file of character type. Now, names of all the files are 10 characters, so it'll be 10. Value, I'll put just books 2. And I'll declare another variable called, 1 second. Oh, not even, I don't know, declare another variable. That's fine. Okay. So this is what I want to do. I want to check the object for the following file called books2. By file, we mean there must be an object by the name of books2. That's what we are checking. And then this could fail, or this will not fail, depending on if you have books2 or not. If it fails, then I want to monitor the message. And my message ID is CPF9801. Remember, that's for object not found. And I will execute send program message object not found. Or I will say object file not found, So that's a monitor mon message with that check object command. And if I make this far, that means that program ran successfully. If it is an error, I will never get to see the output of line 8. If the program is not an error, only then I will get to see the output of line 8. Okay. Now let me compile this. Oops. Oh, it is CPF. I wrote CPG. CPF. Okay. Okay. Now what errors do I have? Number of positional parameter exceeds a limit of 4. Oh, message. Okay, cool. Yeah, forgot to include the message part. So when I run this program and pass number 20, like call number 26, notice books 2 is not found because we do not have anybody called books 2. So you must also see the same error message. But remember, the program didn't crash. My program was able to successfully handle the error and was able to work with the error and tell the user what really went wrong. Okay, is everybody caught up with this example?
Yep.
Okay. Next, what I would like you guys to do to also run the same example with a file found option, I want you to right click on your library, go to expand to, and click on data files. Right click on your library click expand to and click on data files. Everybody got some items that end in DTA?
Oh, yeah. Variety of them.
Yeah. So use one of those in place of books too. Like I have books. I have books. Where is, yeah, I have books. So I'm just using books. So you use one of your object names, save the changes, recompile and rerun the same example. Recompile and rerun the same example. This time it will say program ran successfully because the object was found. Everybody get to see the message that the program ran successfully message? Okay, cool. Okay, so guys, we'll stop here today. And next time we will, as we start moving to chapter number 13, which is about parameter passing. So we will then learn about how you can pass parameters into the program. And then we will dive a little bit deeper into the mon message as well. So we will do a combination of the two chapters that way. Okay, guys? So what we have, what is assigned to you for this week is you have been assigned a quiz, which will be your quiz on chapter number 9. And you have been assigned chapter number 12 review questions, and there are 4 of them that I've assigned you. Both items are due by next week, Wednesday midnight, which will be the 29th. And that's all for tonight.
I can't see it yet.
Oh, hold on a second. Okay, refresh now.
There we go.
Okay, cool. I'm glad you mentioned that. Thank you.
Yeah, I got to save my PowerPoints.
Okay. I have a question for you.
Yes.
It's again, it is my actually, I talked with you yesterday about my work spool file, and I used the dump command in my program, and my program successfully ran.
Mhm.
Still, I did not get work spool file display screen.
Okay, we can have a look at your individual case after everybody leaves.
Yeah, sure. Thank you.
And for everybody else, that's all for tonight.
Have a good week.